It's great to see the turnout here, second day of a Spark Summit. My name is Rahul Farshi, CTO of Zoom Data, and I also run our labs organization at Zoom Data. So what I'll get into today is a little bit of a preview of some of the things we're working on in labs. We'll get into some of the thoughts behind how we think about streaming data and why that's important from the BI perspective, but also how that's different. Just so I can get a sense of the general audience, assuming everybody here at Spark Summit has heard of Spark, how many folks are actually using Spark or using Spark streaming? Probably about half. Awesome. So when I was at Spark Summit East, I think it was maybe about a quarter of the audience using Spark streaming or Spark. So that's great. So let's begin. So first, let me kind of introduce streaming at Zoom Data. At Zoom Data, we work with BI and visualizations, but we also enable that from a streaming perspective and in a very unique way. So all our visualizations, they need to react to new data as it's coming in, as it's being presented to the users. Users need to be able to pause, start, stop, rewind, go back in time, all to provide some context around the data that they're looking at as it's coming in. They need to be able to also look at things from the perspective of maybe the cumulative history or rolling hours, rolling windows, all those window functions that exist. So why do streaming? Why even bother with that? So one of the key things as you want to look at your streaming use cases and from a BI perspective is data freshness. So more and more, it's not enough for the business to be able to react to what's going on in their environment without the freshest data possible. And this has caused a lot of our customers to move from mainly batch operations in terms of their data ingestion infrastructures into more of like a continuous loading and streaming kind of paradigm. So we see that really taking shape a lot more from the industry. The second is the time to analytic. From the time that the data is made available in the subsystems, in the data stores, wherever you're landing the data, to the time that you actually can produce an analytic that the business can consume, we want to be able to cut down that time dramatically. So we want users to be able to interact with the data, be able to make and discover those insights very, very quickly. Because in most of the streaming use cases that we're seeing, that the utility of the data that's coming in has a finite time frame. Meaning, if you're in the ad tech business and you're doing automated bidding, you've got maybe an hour window where you can affect a campaign and make adjustments and changes to that campaign. So the time to analytic is critical. And then you also want the business context. So just going back to that same example on the time to analytic, if you're looking at your campaign analysis, maybe you're making a decision based on what's coming in on your live feed, but you also want to know what happened like last year. So if you're looking at a campaign that's running over Thanksgiving on Black Friday or something like that, you want to look at the previous year's results as well. So how many folks have implemented a streaming job and or have been successful with that in the audience here? Okay, great. So probably all very familiar with some of the challenges, but let me highlight a few of them. So one is time. So time is really critical in a streaming application, but which time? The time that the event occurred, the time that the event was landed into the data store, the time the event was processed and enriched, and what time zone? That's always a critical issue. The frequency. So there's a lot of streaming applications that look at frequency. We could always get a lot of questions about how we handle high frequency applications. And so for a BI tool, for a user that's consuming an analytic on a screen, it's like so much you can take as a human being coming at you at any given time. So frequency needs to very often be buffered or rolled up to something that's consumable, like a second, 5 seconds, something that's consumable by humans. Retention. So when you think about streaming data, you're landing it somewhere. Well, how long are you keeping it? Are you keeping it till the end of time? Are you keeping it for a distinct period? Is there a time where it's particularly still of utility, or should you roll that off, maybe move it into other systems? Synchronization comes in when you've got multiple streams. The common thing to synchronize on is time, but you may synchronize on a customer or other attributes. And then order, I think, is an important thing. How do you capture the order of the messages that are coming in? How do you deal with out-of-order messages as they've come in? And then updates. And updates is particularly problematic, especially in enterprises, where enterprises don't really deal with immutable data. They like to do restatements and those kinds of operations, which makes it very difficult to then capture those changes and articulate them. So at Zoom Data, we've always done things with streaming. We have a historical kind of stack that's very typical of most enterprise software. We work with a JMS queue to receive data. We can manipulate that stream. We land it in a buffer for us that's been traditionally MongoDB, and then you can interact with the data. Our customers typically kind of do that from a custom code perspective, but and what I'll preview today is kind of this revised stack that we're seeing more and more of our customers start to implement, and what we'll be implementing in our product in the near future. So, which is receiving data via a queue like Kafka, utilizing Spark streaming to process and land that data, holding that data in some substrate like that we want to be pluggable, and I'll show how that looks in a minute. And then interacting with the data. We want that to be pluggable as well. Like bring your own visualizations, hook into that streaming infrastructure, and be able to get all the goodness out of the underlying platform. So our cast in this kind of demonstration is going to be a stream. So you can use Kafka, Kinesis, or JMS queue, your processing fabric, Spark streaming, any kind of landing area that what we would recommend is something that actually can support like mutable data, restatements. It's not going to give you a whole lot of issues with that. And we've been working with MemSQL, Solr, Kudu, several others that work very well in this paradigm. So here's how it looks. We've got a streaming server, and that helps us set up a job for Spark streaming. And that job consists of a number of different configurations. It consists of a pointer to the Kafka queue or topic, a parsing mechanism on how to parse and understand messages off of that, whether they're like CSV, tabular, or Avro format. And then any kind of roll-ups that we need to do. So like I mentioned, we need to make sure that the stream is consumable by humans. So if we need to aggregate things up to like the 5 second interval, those are things that we would want to define as part of the job. And then we utilize Spark streaming to take that job and execute that. So we'll submit into Spark and then stream that data to, in this case, a Solr index. But you could substitute any given landing area you want from there. So from the rest of the application, our Zoom Data application software interacts with this streaming server to provide both setup of the source and the GUI around that, but then also like the ability to query, search the data. And so what I'll demonstrate today is some of that ability to query and search through the data. So why do this, and why set up on this kind of stack? And really what it comes down to is scale out. So one of the things we want to make sure that we enable from the Zoom data perspective is the ability to scale out across multiple different dimensions. So on the ingest layer, we've got Kafka in the mix there that provides a great deal of scale out from ingest. And you can ingest as you can have your producers submit data into topics. You can do additional lightweight transformations or utilize your streaming infrastructure to do that and republish onto topics. From the scale out of the stream fabric perspective, we found Spark is really, really great. From that perspective, we're able to get some degree of horizontal scalability with our Spark streaming jobs. And then some of the functions that are available there, and we're really looking forward for the 2.0 APIs for Spark streaming as well, to give us the data frame API, the windowing, and all of that. And then the landing area, you want to be able to have a nice horizontally scalable landing area for the data to persist. On our streaming server perspective, that we keep fairly stateless, so that we can also scale out and load balance that if we need to supply additional queries or handle a large number of concurrent user interactions with the data. So what I'll do is now kind of walk through a bit of a demo that puts all of these pieces together. And I'll ask the audience to help out a little bit later on as well. So to keep us all grounded in the concepts, let's think about a fruit stand, or and the ability to like process fruit orders. So fruit orders are going to be our messages in this case, and buyers can make orders via an API, and we'll keep that API SMS. So in the diagram below, we've got an SMS service that, and we've got a Kafka producer that's going to pop messages onto the Kafka queue. We've got our Spark streaming job that's set up, and I'll show that. That's going to execute and consume those messages off the queue, and then stream them and land them into Solr. And we've got our streaming server, which will enable interactive query over that source and provide that interface back to the Zoom data visualizations and APIs. So now it's time for the demo. Just flip here. So just to make sure everyone understands, it's a live demo. Nothing is guaranteed to work necessarily, but let's see how we deal. So just to make sure that everybody understands, this is real. We've got our very familiar Spark Master screen up, and we've got an application running, which is our SMS Live application. Clicking into that, we just have 2 executors running quite modestly. This demo infrastructure, and then we've got our job running. So we're taking a look at the streaming point, and what I'll do is I'll ask one of my colleagues to start utilizing the API that we've defined to start putting some messages out there into Kafka. And what we should see is a little blip that will indicate how many transactions per second we're utilizing. There we go. So you can see we've done so far 2,000 events per second off of our stream. So what happened here? We put a bunch of messages onto the queue. The streaming jobs executed and pulled the messages off and landed those into Solr. So what we have here looks like we have a couple of fruit orders, one for oranges and one for Kiwi. So we can start to generate a little bit more load, maybe pop some additional messages up onto the queue. We should see some additional blips. There we go. So some more coming in, and we see those there. But let's leave this screen up for a little bit to show how we interact with that live. So as messages are coming in, these visualizations are interacting with Solr, and so there's more of these fruit orders coming in. So what's significant about that from the streaming perspective, and for BI visualization tool? So as an analyst, I'm sitting here and I'm looking at this, and that's kind of neat and cute and whatnot. But we notice this time bar down here that allows me to, right now I'm looking at cumulative orders. I can take and move that to a different time period and look at that. I can unpin that and start to look at a rolling interval and see that window over time. So let's start to get some folks in the audience involved and see if we can't have some better understanding about what's going on. So we've got a dashboard here, and I can ask folks in the audience to text your fruit and the quantity to this number, and we can see if we can't start generating quite a bit more load on the stream as it's processing. Come on, guys, I know you can do it. There we go. All right, now we've got some audience participation here. So as you can see, we've got our transactions coming in. They're coming in also on the Spark streaming job. And we get some nice variance there. Looking back at our viz, we start to see what's happening. As it's happening, and this kind of speaks to why we have this separate landing area and retention area. Why aren't we just visualizing off the stream and holding everything in memory and all of that kind of stuff? Well, we want to be able to ask questions of the data as it's coming in. We want to be able to say, well, we're getting a lot of Apple orders in here, and it's kind of not that interesting. So let me just remove that and invoke another filter. And so what we start to see is we've got that filtered out. Let me kind of remove one of my colleagues here from all the other visualizations to avoid that kind of a skew on the top 5 buyers. And so we can start to see a lot of that, the pieces pick up there. Looks like we have some more orders coming in and streaming through. So thanks everyone for that piece of it. We can continue to send some text, and when we have questions, I'll get in there. But let me go through some of the benefits on this. So what we've seen is some contextual expressiveness, the ability to understand what's coming in from the stream, look at that with the context of other things. So we're able to see the data come in and look at that across multiple different dimensions that are with that data. We've got an architecture that gives us independent scalability of any given point in there. So if our ingestion starts to get really heavy, we can scale that out. If we want to increase our throughput on the stream, we can do that. And then as we want to store and keep more data available for providing that historical context, again, let me pop back there. We can provide historical context and look at all the orders. Well, let me just go back to all the available data. So we can look at that total over time. And then we get a lot of the benefits from the expressiveness with Spark and how easy it is to set this up. We're still looking forward to the data frame API and playing more with that. But also, by utilizing Spark and having that work as well on like your traditional Hadoop clusters with Spark on Yarn, we also get a lot of side benefits in terms of DR, COOP, and data management concerns, which is critical from the enterprise perspective. So landing that data into a known store, being able to leverage that, that's how, part of the hardening process of making these capabilities enterprise grade. And so we're not done yet. We still have some work to do on all of this. One of the big things we're working on is cross-stream synchronization and fusion, so that we can enrich the data midstream and combine that with other sources that may be streaming sources or may not be. We've been doing a lot of work with scale-out on Mesos as a way to do more elastic and dynamic scale with this kind of infrastructure, and then schema evolution. So one of the things that is critical from the streaming perspective, especially when you want to do BI, is the schema itself. You've got a particular message with a payload and format, and you're trying to, and when that changes, that can cause all kinds of downstream impacts. We've had good experience utilizing like search-based sources that can handle things like dynamic fields to get around schema evolution, but looking to enhance that kind of capability. And then more extensible landing strategies, again, kind of to be able to tackle some of the more static schema-based technologies to land data. We can take some questions.
What type of sources can you, I'm quite impressed with your UI.
Mm-hmm.
One of the problems with Spark streaming is that there is no proper UI available to see these various forms of data that is coming through Spark and doing any type of processing. So do you read from a Kafka queue, for example?
So part of this is a preview of what will eventually be capability in Zoom Data to read directly from a Kafka queue. We have a little bit more work to solve some of these things, particularly like schema evolution, in a more consistent way to handle a wider array of use cases. But we already do that today with like Kinesis streams, and we have an upload API that lets you send a JSON payload into Zoom Data. And so we already have a good deal of experience doing that. We just want to make it more robust and be able to handle a great deal more of these enterprise use cases.
What can you do right now? What can you read from?
We can read from a number of different data sources. I think we have connectors to about maybe 20 or 30 different sources.
But not Kafka?
Not Kafka, no. So for Kafka, we have to take ownership of the stream. And maybe we can have a follow-up discussion at the booth. I can drill into that with you further.
And is it open source or is it proprietary?
It's commercial software. Yeah. But, go ahead.
Since you touched upon the data schema management, I just wondering how do you manage and define your schema?
So I didn't cover that. We do have a data source configuration. Once the schema comes into Zoom Data, we need that to be fairly locked or static. We do have ways to help, depending upon landing area, address changing schema formats, but that always has that downstream impact. There was one question there, and then maybe here first, and then get there.
Can you talk about how you're pushing the SMS to Kafka?
So the question was, how are we pushing the SMS to Kafka? So this is a demo, but we use the cloud-based service. I think the name of the company is Nexmo.
So there's no cloud-based Kafka connector, right?
Pardon?
Is there any Kafka connector to connect and get messages from the?
No, we wrote a Kafka producer that just has a web endpoint and redirect from the SMS to the web endpoint. Yeah, she's been waiting quite a bit.
How are you dealing with functionality like pause and rewind Can you talk a little bit about the streaming server as well?
Yeah, yeah. So that's part of the architecture of having the landing area. Gives us the ability to pause and rewind. So it gives us a place that we can run our queries and interact. And when we can pause, so we are able to do that from the client. So it makes it very, very simple and straightforward in terms of that pause, rewind, playback functionality. Other questions? I can't see there.
Can you talk about the options for landing area? I saw solar there and other options.
So what we demonstrated was solar, but it could be anything that can support both like ingest and query. So some things like solar, Elasticsearch. We've done work with the Cloudera team on Kudu, with Impala, MemSQL, just anything that can support interactive query on the data and doesn't give you heartache around like the data management for incremental updates and inserts.
Is your Spark streaming job aggregating your time windows that is actually being displayed, or are you doing that post solar storage?
So that's a good question. So the question was, are the Spark streaming jobs aggregating before persistent to the landing area, or are we using the store to do that? We've done it both ways for the demo to kind of have the low latency effect. We just made the interval like 1 second that we aggregate up to, but we've done both ways. It depends on what your use case is and whether it makes sense to do so. Other questions?
Is the
Yep.
code for this demo checked in somewhere in a public GitHub?
It will be on GitHub shortly. More? Okay. All right. Thank you, everyone.